Hello. Hello, welcome to Telemetry Drops. My name is Juraci Paixão Kroling. I'm a software engineer, and I've been doing telemetry systems for a while now, since 2015 or so. And since a year and a half ago, we have Telemetry Drops. So this is a side project from me, Juraci, where I bring every week a piece of knowledge, a drop of knowledge for you when it comes to OpenTelemetry, observability, monitoring, but very focused on the OpenTelemetry ecosystem. For a few weeks now, I've been receiving guests talking about specific things about OpenTelemetry. So we talked about Java SDK performance with Bruno Batista and Jason Plum a few weeks ago. We talked about Weaver with Josh Surratt a week or so ago. We talked to Dan Blanco about hotel blueprints and what they are, where you can find them, what is the purpose of blueprints. And today, I'm very, very happy, very proud to receive also another prominent guest. So Nikola Grcevski, from one of the creators of Vela and one of the maintainers of OBI, so OpenTelemetry BPF Instrumentation. And we're going to have a conversation about what is OBI, how you can get started with OBI, what are the problems that it solves, what are the problems that it creates, and things like that as well. So but before calling Nikola here in to talk to us, I'd like to share a few things around the community. The first one is, I think I kind of hinted about this before, but I'm getting a very good feedback on a side project of this side project. So this is the Hotel Drops. This is a podcast that I'm creating on Spotify, basically using a lot of the AI knowledge that I'm acquiring myself. So I have a huge knowledge base about OpenTelemetry from all of the live streams that we had, from all of the courses that we have as part of telemetrydrops.com, but also a lot of the things that I'm seeing in the OpenTelemetry communities in general. So that knowledge base is now one of the things that we have for that knowledge base is we can generate those weekly podcasts. So the idea is every week, so I generated one this morning. It goes through all of the GitHub repositories. It goes to the important SIG meetings or the important SIG calls that we had during the week, or the events that happened, and so on and so forth. And it makes a summary, a digest of the week for us. I did it for myself because I felt like a lot of was happening around OpenTelemetry and I didn't know what was going on. So I built that as a podcast format for myself. I like to hear podcasts when I'm doing my morning exercises, or when I'm bringing or when I'm coming back from school, when I brought my kids to school, and things like that. So I like to hear the podcast in that kind of situation, and that podcast is helping me. And I learned things about Steph this morning on this week's podcast. So if you are curious about what is Steph, then go to Spotify already, and you type in Hotel Drops, and you subscribe to the podcast Hotel Drops. But don't tell anyone yet. We are starting small. I just want to hear your feedback as well. So if you subscribe, if you hear to this week's episode, and last week's episode is also fresh enough, then you give me your feedback. The voices are AI, and it is really mostly AI generated. A little bit of I'm curating that a little bit, but most of it is AI. But so that's why I don't want to make it such a big noise right now. I don't know how good it's going to be, and I don't know what the people's reactions are going to be. I know that it's useful for me, right? So I'm going to keep doing that for myself. If you find it useful, let me know, and I can keep publishing them. That said, we have a few events as well. So we have a new event next week. So next week on the 25th, if I remember correctly, we have a live stream as part of OpenTelemetry community. So not as part of Telemetry Drops, where the new community managers of OpenTelemetry are going to be interviewing Josh Surratt. So Reese, Adriana, and Julia, they're going to be interviewing Josh. I'll be there as well, just because I'm very curious about Weaver. But the actual star there is Josh, and Josh is going to be sharing a lot about Weaver, and especially for the internal community consumption. So what are the calls that he wants to make for the current maintainers? What is the help that he expects from the OpenTelemetry community in general? So you cannot miss it. This is part of a new series of live streams as part of the OpenTelemetry community. So make sure to subscribe also to the event page so you get notified whenever a new event is scheduled. Still on events, São Paulo, people from São Paulo, people from Brazil. So I'm going to Brazil in 2 weeks' time. Oh my God, this is already close. And we are having a tarde de OpenTelemetry. We're having a hotel afternoon, and that is on the 6th of March. So in 2 weeks' time, exactly 2 weeks' time, at Bradesco Alphaville. So if you are in São Paulo area, you block in your calendars the 6th of March. We have a tarde de OpenTelemetry, a hotel afternoon in São Paulo. We are going to have 3 to 4 talks there. I'm going to be one of the speakers, but also people from Mercado Livre is going to be there. And very likely 1 or 2 other talks that I'm trying to get the speakers to commit to. And the idea is really a meetup, a big meetup, like a half-a-day event where we talk about OpenTelemetry to each other and we learn from each other as well. No vendors, just the same format that I have here in Berlin for Hotel Night, except it's for the whole afternoon instead of being for the night. The registration page is up, and the link is somewhere here. I don't know where the link is, but you can leave a comment here, and I'll share the link to the community event. But if you Google Cloud Native São Paulo, the event is up there, so you just subscribe to that. All right, so that's it. And I think those were the news that I had to share with y'all when it comes to events and things like that. Of course, KubeCon next month, end of the month, but we're going to talk about KubeCon sometime in another episode in the future. We are already 8 minutes in, and I really want to talk about Vela and talk about OBI. So let me call in here Nikola. There you go. Hey, Nikola. How are you doing?
Hey, everyone. Good to see you, Jurassic. Thanks for inviting me over.
Of course, yeah. Nikola, so first, what is the trick with your surname? Is it Grcevski?
Grcevski, yeah, that's the C is supposed to have a little V on top, like the Czech, but yeah, but Grcevski, yeah. Hey, I lost you there for a second. I think you're frozen. I guess technical difficulties. I guess we wait for Jurassic a little bit. You're back.
For a moment.
It's okay.
It's funky this day. So I'm now on my mobile connection, and let's hope that it's stable enough.
Okay. Yeah.
Cool. Nikola, so tell us about. I guess we should start with Vela, right?
Yeah.
So tell us about the history of OBI. So what is OBI, and tell us what is its relationship with Vela.
Yeah, so OBI, like you mentioned earlier, stands for OpenTelemetry eBPF Instrumentation. It's a tool that can produce telemetry, 2 types for now, metrics and traces, in standard OpenTelemetry format. But the trick was to do it for every programming language, every framework in the world, without actually having to manually instrument all these frameworks and programming languages. And the technology we use to do that is in this project is eBPF. So eBPF is like this low-level programming model which lets you add functionality to the Linux kernel. And with this functionality, we are able to sniff packets, understand protocols, and produce telemetry just like you would from any SDK instrumentation. And so what's the relationship with Bela and this project? Well, the project itself, this OpenTelemetry eBPF instrumentation, or OBI for short, started out as a Grafana project about 3 years ago. And the name for that project was Bela, Grafana Bela. Started as an internal Grafana. It was always open source, Apache friendly license, however, it was Grafana owned and maintained. And yeah, pretty much, 2 years ago, we had the first release of that project, Grafana Bela, but we started 3 years ago. About this time, 2 engineers at Grafana, myself and Mario Macias, project was later donated to OpenTelemetry, I think around maybe 8-9 months ago, and became well known as OpenTelemetry eBPF instrumentation.
That sounds about right. Why is it OB and it is eBPF? Can you tell us the story behind it?
Well, I guess 2 reasons. eBPF, I guess people now in certain circles, especially the purists, call it just BPF. They don't use the E sort of prefix anymore, and the E was always lowercase, so not really that important. It stands for Extended Berkeley Packet Filter, but the underlying technology is the Berkeley Packet Filter. And yeah, so the extensions happen, but over time people just call it BPF. And also the second reason was like much easier to make an acronym that can be pronounced with the B. So eBPF, so OB instead of OE or something that nobody can pronounce. So OEI was a little bit of a less easy acronym. And, OpenTelemetry eBPF instrumentation is already a mouthful, and you get tired saying it over and over. So we needed a short name. So OB.
I love OB. Yeah, the name OB is really good. But I like so the E versus the B, like eBPF versus BPF. So when Bailey started, just telling some people here that when Bailey started, I was at Grafana, right? So I've seen Bela being born there, and I've seen the discussions. You might remember that, of course you do, where we were discussing, should it be a product with E in the beginning, or should it be a B? Because every Grafana product it starts with the letter of the signal or the main technology that it's built on top of, or that it represents. Like tempo is traces, low-key, logs, metrics, Mimir. I think only Grafana, for historical reasons, doesn't. I mean, it's not dashboards, but it's graphics. Or I mean, we are trying to make it fit, right, with the G. But but with when we thought about Bela or the idea, I remember seeing a doc where people were saying, should it be an E or should it be a B? Like, so, and the idea for the B is also because of that. So because the E would eventually be dropped. I think that was the reasoning. Right? So the safest path to the future is B, not E.
That's right. And even like the library we all build today, which is part of the Cilium Go eBPF library, and so it's called libbpf, not libeBPF. So it's really BPF everywhere. When you write the code, every prefix that for the helpers is all BPF. There's never E in front of it. So let's just call it like it should.
So let's. I have a lot of other questions, or we could talk about the other governance sides of the project, like how it got donated, why it got donated, so what led Grafana to donate Bela, and so on. We can go back there, but I wanted to focus on the technical sides as well, the technical aspects. And one of them would be, you talked a little bit about the problems that it solves, right? But can we go deeper there? Like, what are the pains that people have right now that OB is solving?
Sure, yeah, I can. I mean, over the years, kind of the story changed a little bit about that. And when we started a project, I actually had no idea who's this for and what is this for. We just knew we needed to build something for Go primarily. because Go was not easy to auto instrument, unless you add some manual instrumentations or manually change the code, or maybe add a new build time step, like with Weaver, for example, where you can kind of add instrumentation after the build. But having a Go application running in production and you wanted to instrument it, it was kind of hard to add auto instrumentation to it. So that was the initial reason. But then we started seeing other customers have trouble with particularly unsupported OpenTelemetry languages or frameworks. People ran like legacy applications, old versions of Python, old versions of Ruby, weird frameworks that they've cooked up themselves that don't fit quite in the standards that OpenTelemetry is instrumenting. When you go and instrument library by library for a certain programming language, it's a like long tail of things you need to support. Like if you ever looked at the Java auto instrumentation or Java instrumentation SDK, which is the most complete, and you go look through all the packages they support, it's a massive list, like hundreds and hundreds of instrumentations for various libraries, various versions. And this is what you need to do to support the language really well, right? And at the same time, like we wanted to see if we can build something that's just going to be generic, that it wouldn't matter what programming language you chose. It should just work. And I kept on talking. I don't know if you were listening.
No, I lost my connection again for a few seconds, but I'm here again.
Okay. Yeah, I was just explaining that the reason is that we kind of wanted to build something that's would work for any. So it doesn't matter what you run, what framework, what programming language we could instrument, and target those. Target the problematic cases where it's when you have the ability to instrument with a Java agent and it works well, you should do that. You shouldn't bother with eBPF instrumentation. But if you had trouble, you're having difficulty, your frameworks are not supported, you have a backup plan. And that was the main reason we started pushing for the project forward after a little while, because it's good. You reach a customer that's running on an old version of Ruby and Rails, right? And it's easy to say, well, just upgrade. And they're like, oh, well, it would take us 3 years if we dropped everything we're supposed to do for this product. And now we have to upgrade to Ruby, whatever, 5, 6 that the SDK supports. And I don't know.
So this example is oddly specific.
Yeah.
And is that a real case?
Yeah. It was a Japanese customer that we said upgrade to, and they said, well, we estimate it will take us 2 years if we just stopped working on the product.
I remember that case. Yeah. And I think that so to me, that is the moment that I said, like, here is a case where no other technology can help but Bela, or it was Bela back then, but we can migrate that to OBI now, because that is a legacy application, a monolithic application, if I remember correctly. Rails version 2.0 something very, very ancient. Nobody wants to touch that, but it breaks. It needs to be observed, and if you don't want to touch it, then eBPF or observing from the surroundings, I think it is very useful. Now, you did touch that, especially when I went off for a few seconds, but you touched on the Java auto instrumentation and then the Bela or the BPF instrumentation part. Like, what is, in your opinion, the mental model? Like, what is the framework decision, the decision framework that you would use to tell people you should do manual instrumentation, or you should do Bela or OBI, or you should do Java auto instrumentation? It's like, how do I decide? I have so many options nowadays. It's hard to decide. How do I decide, in your opinion?
It's kind of like different for use case to use case. I like to start with a very basic sort of scenario. Is like, you have no instrumentation whatsoever. Maybe you have logging. Everybody does logging, right? This is the first thing we ever learned, right? You put hello world and, hey, my program worked, right? even for debugging, people just add log lines because sometimes firing up a debugger in production is just not possible. And then you want to take the next steps. And if you're nowhere, you don't have anything, I like to say this eBPF is the easiest way to get going. It's just throw it in there, it instruments, at least for metrics, you can get right off the box, full visibility of every service. You're going to get connectivity metrics, which service is talking to what, which one is failing talking to what. It gives you a lot of insight. And then you can push it maybe further for certain technologies to enable distributed tracing. It's a hit and miss, I would say. We're trying to close that gap and make it work better. But it's depends on the scenario of the programming language or the framework used. Sometimes we're unable to correctly propagate the context. And then once you get better at telemetry and you understand the value, I think you should spend time migrating what you can migrate on the SDKs. And this is where I think people miss, so OB gives me distributed tracing, why should I do anything else? And I think it's not the end of the story. Like the language SDKs, specific for that language, give much richer detail about what's going on in the application. They'll tell you, like, let's say you're using Java, right? What OB will tell you that you called a SQL, but it will never tell you how much time you spent in Hibernate layer preparing that SQL statement if that was your performance issue, right? Maybe you're having a slow response, but it's maybe because of Hibernate is spending 10 seconds preparing these objects and it created this query and whatnot. So the SDKs can also get full exception traces, something we don't do in OB. So if you have an error, you know this particular SQL query failed, but if you look at the exception, you might know exactly why it failed. It will give you more details of what happened, where it failed, what you do, and so on. So the SDKs give much richer information, if you will, that I find when you spend the time and devote, you get a lot of payback from that.
You know that I was part of the Hibernate quality assurance team, right?
While you were at Red Hat?
So I do, yes, when I was at Red Hat, when I were there. And I do hope that your example of 10 seconds at the Hibernate layer preparing statements is a fictional one. I hope it's not the real one that you've seen.
It's not. So let me tell you the story. Like I worked at a SaaS startup a while back, when internet was just happening, when the whole SaaS world exploded. And I quit my job at IBM and I worked at a brand new startup. And we built this, we built everything with Hibernate, MySQL, and Java. And then at some point, somebody from sales said, our customers make mistakes when they sort of touch something in the product and they change something and it breaks and it's nobody. So we like to be able to revert, kind of undo automatic in the product. So we had used this extension to Hibernate that would log every change. So it would technically write the previous state. I forget the library name, so it's been a while, but it was really cool. And technically can give you the previous state. So I wrote this code which would try to load in Hibernate the snapshot of how it looked like with your timeline. You say, I want it at this time, 2 days back. So we try to reconstruct everything, all the relationships between all the tables, create a new process in memory of, we call this process graph, and then try to write it back. And it took quite a bit doing that, doing all these queries, populating everything in memory, and then writing it back. It was quite. I mean, it's a bit unusual. I mean, we're probably pushing Hibernate to the max of what it could possibly do, but people do crazy things and unexpected.
I think I know what is that extension. That's Nverse, isn't it?
Nverse, yes. Yeah. Nverse, yeah.
I remember that one. Yeah, that was very cool.
It's really cool. It practically wrote a history table of your change after you made it. It's like a Git for your SQL tables. And it was extremely slow. The tables were extremely slow, but it didn't matter. They had no indices, no anything, but it was write only mostly, except in that case where we wanted to revert. It was, it was great.
Nice. So we talked about the cases where OB shines. Now, before we go into traces, because that's what I'm mostly interested in, I heard a claim from somebody in the same area of the ecosystem, but not exactly from Bela or OB, where they said eBPF instrumentation is like they really said that it's free, it's no touch, no overhead. Like it is the holy grail. Is it really like that? Like, is it no overhead, no touch, perfect instrumentation, or not perfect? They didn't claim perfect, but they did claim complete instrumentation. Is that what we can expect from instrumentation at the kernel level, at the eBPF level?
Right. Okay. Yeah, let's talk about that. I mean, I agree with the statement no touch, because I mean, technically you can drop this on a completely uninstrumented, even like Kubernetes cluster with many, many services, and it will instrument everything. You'll get telemetry from everything. And if you want to take it out, you can take it out. I mean, you know how we have this concept? It's always like you can push this to the extreme. You have this concept of you should be monitoring at all times and doing all these things. And maybe you should sample because it's too expensive. If this eBPF worked really great, you can actually push it to extreme and said, you can monitor just the bare minimum. And when you get into trouble, you can just turn this on and get everything. And when you're done with work, you just turn it off. So, I mean, if this worked great, technically, theoretically, in the future or ever, you could potentially never need continuous collection of traces. You just do it on demand ever. Because it's so easy to drop in and take out. It doesn't destabilize the system. You can cleanly take it in and out without any disruption. You don't need to restart any services. That's the promise of it. You don't need to touch anything that's running. You should just be able to come in and come out. The no overhead aspect, I disagree. There's overhead to everything. The question is, how visible would it be? And how much detail of information you want to gather. Like, let's be real. Like, when you want to do anything with eBPF, what you typically do is capture data at a kernel level, ship it to user space, then the user space component turns into telemetry, useful information, and ships it to some backend so you can review it and monitor and run SLOs on top of it, alerts and whatever. The way it does it, when you think about it, it puts these interrupts into the kernel or application code. So when your program reaches this point, it runs, like, switches context, runs a little bit of program code that captures a signal and continues. Now, this is an interruption to the program. If you do this at high request volume, you're going to feel it. There's no doubt about it. Something is context switching you around to capture this telemetry. Yeah. Now, compared to traditional instrumentation, it's much cheaper, but it's not zero overhead. Let's just not pretend that there isn't anything, right? It's much lesser overhead, but if you drive this hard, you're going to see it, right? And we've certainly had a couple of issues open in the OB project when people have tried this. They'll create a service that's really, really fast, like responds in microseconds, right? And then they drive it with 10,000 requests per second. Well, yeah, you drive it and you turn on OB, trying to capture 10,000 requests per second, connect this, and yeah, you're going to see it. Yeah. And your application will slow down. But if you did this on this application with Java or Go, and you had this kind of overhead of creating traces, yeah, it would be probably, instead of 20% slower or 30% slower, it would be 3 times slower. So,
and I think it ties back into the conversation that I had with Jason and Bruno a few weeks ago, where so they did the measurement, like they benchmarked the Java SDK with a tracer, without a tracer, but with OpenTelemetry API and SDK, and the Java agent as well. They saw very interesting numbers, so the full episode is there, and you can watch that. But one of the things that that confirmed what we've been thinking since, I don't know, since the open tracing days even, is that most of the time, for most of the applications, this is not going to matter. Because the overhead in general, not only BPF or Java, but in general, because most of the applications are not that interesting. And if they are interesting, they're doing something that is cool, like talking to a database or talking to another service or doing some I/O. Like the moment you do I/O, then performance overhead doesn't matter anymore.
Exactly.
So,
and but you can create these pathological cases and just say, oh, this is so slow. But at practice, like you say, it doesn't matter. Like as soon as you're talking like SQL database, like I mean, your response times are no longer microseconds. You start to get to milliseconds, and adding a microsecond overhead on top of it, no big deal, right? But I've seen, like, I worked at Microsoft for eBay for a while, and we had this service that I was doing, like checking for whether something is like, are you allowed to see this person's profile? Kind of thing. And that service served like massive volume of requests. It was essentially a hash map in memory, right? And then you come in and hit it through APIs all the time. And every service in LinkedIn would check that before it had to do some action. Yeah, you turn on something like that, this kind of instrumentation, you probably pay the price.
Of course. But even at those companies, that is the one really, really hot service. Right? So not all of the services within that organization are going to have the same kind of load. You can have a default, a standard instrumentation decision for the whole company, and then make exceptions for that very hot, that real-time transaction that you need for your trading application. Like one is critical. Right, so that one you don't want anything at all, like no instrumentation, like nothing at all. Every CPU cycle, every counter match matters. But for all of the other cases, observing that really matters most or more. So than not observing. I want to go into a different direction now, Nikola, and it is on the tracing side of things. You mentioned at the beginning that OBI can do metrics and traces. I come from the traces land. I love tracing. And one of the most difficult things to do with tracing, and I remember talking to people, perhaps even you, when in Manchester, that I had. So one thing that is very difficult with tracing is if you are not part of the main code, if you're only watching from the boundaries, you cannot correlate the incoming connections to the outgoing connections. You need the context to be propagated within the context, the process within the request, so that you can do the correlation of the ins and outs. Like if one in means 20 out, then I need to know which 20 are connected to this one here. Are we there yet? And then I remember saying to a few people over the years, like, if you can crack that problem, if you can make the ones and the 20s being connected to each other without having to look into the application, without having to instrument the application itself, then you solved a very hard problem. Are we there yet? Have we fixed that?
Not fully, but I'd like to think we're getting close. And I'll give you the current state of things and the current issues we have in progress. So we initially, when we did this work, we implemented this for Go first. So that was the language we supported well. And the way we did that is we set probes into the Go runtime. Because Go is a really well-behaved in terms of how things are being built. Like every program looks more or less the same. Everybody's using the Go standard libraries. Yeah, there's few, but the core, everything you deal with, Go routines, sending, receiving data, it's all the standard library. And you tap into those aspects and then you can correlate them, right? So there's a place in the Go runtime when a new Go routine gets created, you know the routine that wants to create it, and you know the new one that's going to start, so you can correlate them. So that was the first attempt, and Go worked straight off the bat. Then we added support for threads. When a thread launches another thread, we correlated based on that. However, that only works for very simplistic kind of scenarios where people are not using thread pools. And who doesn't use thread pools, right? Most people use thread pools. Let's be real about that. So thread pools were a nemesis for the longest time. So then we focused on the easier languages. So Node.js has an event loop. For a while, that worked with just pure eBPF because we were able to tap into Node.js itself. But then in Node, I believe 20, they changed and moved a bunch of the code into JavaScript. So for Node, we actually inject a tiny, tiny agent through the debugger interface automatically and tell it to kind of suck in a little bit of code that helps us kind of catch those transitions. It's kind of nifty, but so OB will see that it's Node.js and they'll just say, hey, take my agent, please. And you don't know what's happening under the covers. You don't need to restart the application. It's what it works. So we were successful with that. Then we found a way how to instrument Ruby on Rails, which runs this Puma library, which have a typical reactor framework. So we added probes into specific parts of the Ruby runtime to catch this. So now we're talking 3 languages, right? Go, Node.js, Ruby. It's all starting to work, right? Python mostly works unless you use async Python. So async Python is something we're currently looking at. We have some prototypes for async IO, but we found we probably need to do a little bit more for UV-Lube. So I like to think Python's next. And then we try to tackle Java, which is a lot of people run Java, right? And Java was interesting. So what OB does right now to tackle Java is same like Node.js. We have a tiny, tiny agent which can be dynamically loaded. Unlike the Java SDK agent from OTel, which has various design choices that prevent it from dynamically working for many frameworks. You can load it dynamically, it's just not going to instrument as well as it would if you're on the start. The OB agent is able to do it and can be dynamically loaded. It has no dependencies whatsoever except on ByteBuddy. And so it's tiny and it does the job. So we have this helper that tells us a little bit of the context as the thread pools are shifting data between them to how should we track this. We found .NET is actually quite good. .NET was a nemesis because it's even more complicated than Java, the thread pool mechanics, and it's all done in user space. However, fortunately for us, .NET auto-propagates. If you have an incoming trace parent, they'll do it. So there we use we're about to commit the code, but it's kind of a silly trick. We kind of watch what's happening on the wire coming into the .NET application, and if it has trace parent, we're like, okay, you're going to do it. You're going to propagate. We just need to read the information and make it part of our telemetry. But if it does no trace parent, we actually inject one on the incoming request, and .NET propagates it for us. So it's kind of a trick. So now we're talking Ruby, Python soon, Java, .NET, Go. So the languages are adding up. So this is state. So .NET and Python will soon, hopefully Python async. With that, we'll close majority of languages. And one final one we've been thinking about is Rust. Primarily trying to tap into the Tokyo runtime because everybody that's running Rust is using this, or it's the most popular framework for sort of async requests and so on. So it's getting there. The story is like it doesn't work everywhere, and what I've said today works. Context propagation only works for HTTP. Once we complete the picture, we'll try to get HTTP2 and gRPC working on top of that. But as you can see, it's not as easy as the protocol parsing and just extracting the protocols and understanding that you're a SQL database, so I can capture your SQL request and timings and whatnot. We still needed to get a little bit more specific to be able to do this context propagation.
I think it's really cool. I think it shows a lot of ingenuity there, like the small things that, like, it's like a surgeon, like you know exactly
Yeah.
which parts to touch and
Yeah.
then to open and then inject something and close again, and like
Yeah.
it feels very surgical. And I think this is really interesting. This is a very nice piece of engineering. And looking back at the perhaps the comments that or the mindset that I had before this conversation, I think that what I can take from that is there's no generic solution, and it's very likely there's not gonna be one, not for the foreseeable future. But at the same time, some decisions can be made for specific popular frameworks, languages,
Yeah.
and things,
Yeah.
and solutions can be built by them. I think the interesting question then to follow up, perhaps some other time, is how does that interact with the ecosystem as a whole for OpenTelemetry? Like, I know there is something called Injector, and we're going to talk about the Injector, I think, next week with Michele. So I'm receiving Michele next week here to talk about Injector. And it would be interesting to see how the whole picture looks like when we have OBI, when we have Injector, when we have the agent specific or the language specific agents and SDKs. Like OTel, in my opinion, OTel still has to feel like one solution. And I think the good thing is we have a few solutions, which is way better than not having any solution
Not having
in the
any.
first
Yeah.
place. Yeah.
Well, I have an opinion there. I don't know if I'm involved in the Injector project. It's a really fun project. And we started using it in Grafana. We want to build a package where we're going to combine OB and Injector with the SDKs to do a combination of instrumentation. And so, I mean, OpenTelemetry, there's discussions that we could maybe package them together. So the Injector, where the language is well known and in kind of auto instrumentation works really well, then you fall back on the Injector. And then anything else where, oh, it's Go, it's Rust, there's all these things that, oh, it's not compatible, we couldn't instrument, and then you fall back onto OB. And that takes care of the rest, right? With some warning to the end user that, okay, this is partial or this is not high fidelity, or things like that. So I think we're going to see there's a packaging SIG being formed. We're going to see effort being put into packaging OTel. And when you get OTel, you get everything in the best form that's available to you. I like to think that we can take OB to the next level and make it work together with the SDKs. Because there's been one outstanding issue that's been from the very beginning. One of the advantages of eBPF instrumentation is that it starts to track the time of a request as soon as it hits the wire, which means we see it as it comes in the kernel, right? Which is different than the request being served by an application. I know from my experience that this can be very misleading. When an application is overwhelmed, right? Say you have something can handle 100 requests per second, but you're sending 200. Your instrumentation from the Java SDK will be wrong because it only measures the service time. It does not measure the time that the threads are waiting on the queue to be served because the instrumentation works on Netty when Netty takes over the request to serve it. But what happens before Netty, how much this request is waiting on the Netty thread to become available, you just don't know. Well, eBPF does. So you can get vastly different numbers, like if you have an overwhelmed application. But isn't that what we want at the end? Like, we want to know when our application is in trouble, right? So like somebody sending too many requests, we think we're okay, but our customers are not actually getting good responses from our application. So we'd like to be able to know when that happens. And I think eBPF is the solution for that. And so what we've been discussing is that maybe eBPF as a base layer can run all the time, even if you're an SDK instrumented application, because it could augment the timing somehow through span events or maybe through additional spans that could actually inform the end user that, hey, yeah, this is actually the total time is much worse, and you have this queuing time that eBPF reported on top of the existing. So I'd like to think that in the future it's not this one or that one, that you have to choose, but you run both and you're going to get best of both worlds. You get the baseline, really kind of correct information in terms of timings and accuracy, and then you get the rich details from the SDKs where you have it available.
I think this is a very interesting situation. I think the each layer deserves its own observability. I remember a talk that Fabian from Grafana he delivered, I think, at some Java event. I don't remember which one.
Yeah, Vox based, yeah.
Was it? Okay.
Vox, I think,
that was, it was exactly the example that you've given. Like the demo that he ran was, look at this dashboard, everything's fine, except that look at how painful it is for the users. Like they are waiting until, I think it was a Spring application, so Nadi probably. Look at how long people are waiting in queue to get the request. Once it is accepted, then it's fast. So everything is green for you. Yeah. And I think it is very valid. Now, it does beg to the question, and something that is very, very close to my heart since last year, which is how much isn't too much? I've seen examples of and we talked about that already in private, but how much is too much? How much are we getting automatically from eBPF that we should not be getting? Isn't there a danger that we get a lot more useless information than what we should be? I think you touched kind of a good point before, where keep it there, keep it at a minimum. Whenever there is a problem, something external signals Bela or OBI, and then it tunes up the instrumentation, and then you get more information. I think we're not quite there yet. Where are we? Are we on the noisy side of things, or are we on the quiet side of things?
That's a good question. So we as Grafana kind of like this mode for most of our customers that we run OB or Bela, whatever you like. It's more OB now than it is Bela, slowly. And we just enable span metrics and service graph metrics. That gives a good baseline for most people, and it's super cheap. Like from how much you're paying for your telemetry. It doesn't give you the details and insights of the tracing, but for a lot of people that just want to know when something is down so they can go and look at logs and whatever else is going on, especially people that don't have complicated setups, it still gives you the information of where the downstream failure is. You know where the point of actually the red further downstream is. So you kind of see the initial red spot and go back into that application and check. So we find a lot of customers just stick with that. Customers that are fully bought into tracing usually run this as a sort of a backup plan compared to the SDKs. And they run tracing full on. I've seen different situations. People just throw in tracing and just hope for the best and pay large bills and whatever. They just want to be able to have the ability to debug anytime they have an issue. But you also have the customers that are really savvy, which they've fine-tuned tracing to the point where applications that are high volume, they just manually go and add in this specific situations when they want to trace, and everything else is eliminated, because these things don't care. Like if my admin stuff fails, that's okay. Like that's for us to try to use the API. So I don't actually want to track that and pay the cost for that API. I don't want to pay the cost for the health checks. I don't want to pay the cost for the liveness checks and all these things that would naturally be reported, right? They fine-tune that. So depending, I think if you're running something at really high volume, you have to make these choices to decide where to cut, what to choose, and so on. Yeah, it's a difficult choice, but I think we're going to get to a future where there was an article, a paper somebody published, a research paper where they actually used eBPF to run anomaly detection, to detect when this hardware you're running on, the service is struggling all of a sudden. Like you were running fine, but all of a sudden your CPU is spiking and this and that, and to kind of use it as a signal to turn on more telemetry. So I can see that actually happening with eBPF, not with the injector, because all this requires that your services restart. And I don't know how to work around that. I was hopeful that I can get maybe at some point the Java agent to work fully dynamically to be able to be injected. And I had almost this working. I had a branch, I still have the branch, where this worked for most optimizations, maybe not some AWS instrumentations, but since then, I think the Java agents are doing refactoring to be able to kind of on the fly debug certain things and so on. I don't quite understand it. There's this new initiative, and the way they're changing the code is just not amenable to dynamic injection anymore. Like many optimizations, just instrumentations just don't work. So that ship has sailed, in my opinion. So the last 9 months, all the work that's happened is sort of driven in the other way. So it's kind of hard to turn up the instrumentation when you kind of have the inability to restart. And maybe the future is that we run with dormant SDKs. You know, they're there, they're loaded, but then they're not producing telemetry until you tell them to. And then you run OB in the background, and when they really need this on, then you somehow send the signal to these processes, and they pick it up, and then they start generating telemetry, and then OB notices it, and they shuts itself off, and then, which we do right now. Like when we notice an application is exporting telemetry, it will stop. And then you can maybe send the signal to turn it off again. It will be a cool project. I think it's doable for many programming languages. Most programming languages, you can register a signal hook that OB can send. Tell the program that, hey, you need to wake up and start sending traces. Could definitely be done.
Nice. Nikola, that's very insightful. I love the conversation. And I think we could be, I don't know, talking for another couple of hours easily.
Yeah.
But thank you very much for being here, for accepting the invitation to talk about OB. To wrap it up, I think I'll just ask you, if people are interested in OB, how do they get started? Where do they look for information, and how do they get help?
Yeah, so all the docs and getting started guides are now available in OpenTelemetry.io. In the docs section, there is a separate section about auto instrumentation, and you can find OB in there. And for, help, we are very active on the CNCF Slack. There's a channel, OpenTelemetry eBPF instrumentation. Lots of people participate there, not just Grafana. That was one of the biggest benefit ever from going to OpenTelemetry, is I can't explain how unexpected and how happy I am with the way that things have gone. Because, I've been on other projects, participated that weren't really exciting, but I feel like every time I go to an OB SIG call, it's just like all these ideas, people talking from different companies, people join in, and there's been a lot of activity, and it's going great. So, and there's plenty of people that are willing to help on the channel. Also opening issues, GitHub, that always works.
Cool. Nikola, thank you very much.
Thank you, Jurasi. Thanks for inviting me.
Of course. And let me, so thank you, Nikola. And for you all watching here, so next week we have Michele talking about the OpenTelemetry injector project. So you cannot miss that one as well. And see you next week.